Hello everyone. Today we are continuing our work with transformations by talking about reflections. In the previous set of notes we were looking at translations where we were moving an object up, down, right, or left. Now today we are also moving an object, but this time we are flipping it over a reference line we're going to call the line of reflection. We'll start off with some very simple objects, just points. We'll talk about notation. Again, we're using that prime notation we learned about yesterday. And then once we get down to example 2 and below, we have lots of examples to show lots of different possible combinations. Today is the day where it would be helpful to have several colors. So I would suggest 2. I'll be using 3 in some of these cases. If you have that, that'll help keep your information organized, because there's lots of lines we're drawing, lots of figures we're drawing, and sometimes they overlap each other, and it's easy to lose track of that information. So let's talk about a reflection. A reflection is a transformation that uses a line like a mirror to reflect an image. The mirror line is called the line of reflection. Can abbreviate that as LOR. Okay, line of reflection. So let's see if we can figure out where that line of reflection should go on this first example when we're given a pre-image and an image. So the pre-image comes before the movement, and the image, you can see with the prime notation, comes after the movement. So we're told in example 1, here in part A, if A prime is a reflection of point A, where is the line of reflection? Well, this line of reflection has to be exactly halfway between the two. So let's count the total distance, which is 1, 2, 3, 4, 5, 6. Half of that is 3. So 1, 2, 3, that is where we would expect to find the line of reflection. Now, when you draw this, it should be dashed, not solid. Because if it's solid, then it's really there. It's part of our figure. If it's dashed, it's not really there. And that's the case because this line of reflection is just a reference line. It's not actually there. It's just a visual aid to help us show how an object is going to be reflected. So if you count the distance from that line of reflection to a point, you should have the exact same distance on either side. So when we are reflecting an object over the line of reflection, we're going to be doing a lot of counting. We're going to be counting the distance from the pre-image to that line of reflection. Then we'll flip that distance to the other side, count the same distance, and that will tell us where the reflected image should go. Now the challenge here is remembering how to write or read these equations of lines that are vertical and horizontal. So where is this line of reflection? Well, you can see that's where it is, but how do we describe it? It is a vertical line at, and this is its equation, x equals 1. So we have to do a quick review on how do we write the equation of vertical lines and horizontal lines. So you may have encountered last year in your Algebra 1 class this phrase called vux hoi. It's a series of letters to help us remember what to do with vertical lines versus horizontal lines. In your Algebra 1 course, you're also worried about the slopes of lines, whether they are undefined slopes or zero slopes. We're not so concerned about the slopes in today's lesson, but it's part of the phrase that we use to remember how to write the equation of a line. So a vertical line uses only x in its equation, and that's what we see here in this example. A horizontal line uses only y. So we're going to be writing equations of lines or reading them. Some of them will be slanted, and some of them will be vertical or horizontal. So this is information we need to use. Part B, what is the equation for the line? Oh, we already talked about that. I answered that question up in Part A. Part C, if point B is located at negative 4, comma 5, let me plot that point. 1, 2, 3, 4 to the left, 1, 2, 3, 4, 5 up. There's point B. If point B is reflected in the same line, then where is B prime? Well, let's count the distance from that point B to that line of reflection. What is that distance? 1, 2, 3, 4, 5. Okay, so count 5 units on the other side. 1, 2, 3, 4, 5. That's 5 units, and that shows us where B prime is located. So you can see in blue I'm drawing these lines here representing our counting distance. You don't actually have to draw that, and we'll see that illustration here in the next example. So the question is, where is point B prime? B prime is located at, so again, start at the origin. 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5 up. So 6 to the right and 5 up. If point C is located at 1, comma negative 1, so go back to the origin. Here's 1, comma negative 1. There's my point C. And it's reflected in the same line, where is C prime? Well, you'll notice that point C is actually on the line of reflection, so its distance is 0. So that means we're not going to be counting any distance on the other side of the line. We take this point, we flip it over, and it lands right on top of itself. So there's actually 2 points right here. You can't tell, but there's 2 points. C prime is on top of C. C prime then has the same coordinate. So we notice some interesting things. We notice that the line of reflection is exactly halfway between the 2 points. And it also turns out that we have some perpendicular lines. It turns out that if we look at the line of reflection and we look at these counting lines, that we end up with a right angle. So we have perpendicular lines here, and that means this is a perpendicular bisector. And that's something we had looked at in the previous unit when we were bisecting a segment. We did a construction and we created a bisector of a segment. If you imagine these counting lines as the segment you are bisecting. So that's represented in a very abstract way here in the middle of the page with this diagram. Here they are plotting point P and point P prime, and then they're connecting them with this line, and it turns out that the line of reflection has to be a perpendicular bisector. So that's why you see the right angle, and it's going right down the middle of that segment that goes from the pre-image to the image. So this is a perpendicular bisector. And that's what we're describing here. A reflection in a line, such as line M, maps, that means it connects every point to a reflected point, such as P to P prime, so that each point, one of the following properties is true. In this case, we have a perpendicular bisector. In the second case, if our point is actually on the line of reflection, well, we don't have a perpendicular bisector at all, because P and P prime are actually at the same location, so wherever P is, that'll equal P prime. That's the same. So they're either the same, or we see this pattern of a perpendicular bisector being formed. So let's go to our bigger examples and take a look at example 2 down here at the bottom. And we're going to go through the process of taking our triangle here, and we are going to be reflecting it. We are again going to graph the pre-image. We also must graph the reflection line. Then we're going to graph the image of the triangle with that given reflection, and be sure to label your vertices using that prime notation. So here my pre-image is this triangle DEF, so D is located at 0, 2. E is at 1, 4. and F is at 3, 1. There's my triangle, that's my pre-image. So I'm going to my second color for the line of reflection. Here's my line of reflection, y equals 2. Notice you see only the letter y. That means it's a horizontal line. So I'm going back up to the page. Do you remember when we were looking at this phrase, vux hoi? A vertical line uses only x. A horizontal line uses only y. So because I see only y, that tells me this is a horizontal line. So let's draw a horizontal line passing through the y-axis at 2. Alright, so here's my line of reflection. Make sure it's dashed, because it's not part of our figure, it's just a reference line. Now I'm going to my third color as I reflect each point. Now if you take a look at point D is already on the line of reflection, so that means when it sort of flips over, it's going to land right on itself. So D prime and D are one and the same. Take a look at point E. You count this distance. This distance is 2 units above the line of reflection. So count 2 units below the line of reflection. 1, 2. There it is. That's E prime. Now if you just compare E with E prime, and if you were to draw this imaginary line representing the counting distance that you took to find the placement of E and E prime, notice that it is a perpendicular line to the line of reflection. And the line of reflection is smack dab in between E and E prime. So that line of reflection is the perpendicular bisector of that segment. And that's what we were illustrating in the box above, that perpendicular bisector. If you accidentally place your point off a little bit, well then it wouldn't be perpendicular. And that's how you can check your work. Point F now to finish up is 1 unit below the line of reflection, so count 1 unit above the line of reflection. There's F prime. Connect these, so D prime to E prime to F prime, and back again. You can see that we have now 2 triangles. One is sort of layered over the other as we have reflected it over that line of reflection. Some of the problems that you'll be doing for homework will have you then write down the coordinate points. So for example, here is D, which is at 0, 2. We applied the reflection, and D prime is located also at 0, 2. Point E was located at 1, 4. So after the reflection, E prime is located at, so always go back to the origin to check to see where your new points are, and this is 1 to the right, so it's 1, 0. And lastly, F, being at 3, 1, was reflected to F prime, which is at, so there's the origin, going to F prime, so that's 1, 2, 3 to the right, 1, 2, 3 up, so 3, 3. So we didn't have a table set up for this listing of coordinate points, but on your homework, you'll often see it says list the coordinates of the image, and that's the information that we're looking for there. It's a quick way to check your work when we check it against the answer key. Here in part B now, our line of reflection has only x. So when you think of your phrase vux hoi, a vertical line has only x. So this is a vertical line of reflection. That means it goes up and down. That means it has to pass through the x-axis at 4. So 1, 2, 3, 4. Here is our vertical line of reflection. Okay, but I do need the pre-image on here, so returning back to my first color, I am plotting the same triangle again. D is at 0, 2. E is at 1, 4. And F is at 3, 1. There's my pre-image. It does look the same as the previous example, it's just that we stretched out our coordinate grid because we're going to be reflecting further to the right because of the placement of that line of reflection. So here is my third color as I reflect the triangle. So I'm looking at point D, counting its distance to the line of reflection, which is 1, 2, 3, 4. So 1, 2, 3, 4 on the other side, there's D prime. Point E is 1, 2, 3 units on the left, so 1, 2, 3 units on the right is E prime. And lastly, point F is 1 unit to the left, so 1 unit to the right of the line of reflection gives us F prime. So connect those dots, and that's our answer. So again, on your homework they will ask you, where is D prime, E prime, and F prime located? So let's just jot down those coordinates. D prime is located at 8, 2. E prime is located at 7, 4, and F prime is at 6, 2. Now, a common mistake that I see here is that students will accidentally start counting from here where the line of reflection crosses. They'll say, hey, D prime is located at 1, 2, 3, 4, 2, and that's not right. Make sure you always go back to find the origin. So when you're counting, if it helps, you could kind of put a little dot there at the origin just to draw your attention back to the fact that, hey, I always need to return to the origin when I'm counting my distances for each of those coordinate points. Let's turn the page and take a look at these next few examples. We're looking for patterns here as we continue to look at reflecting objects. So the reflecting itself isn't too hard, it's just a bunch of counting. But as we take a look at certain locations or types of lines of reflections, we're going to start seeing some patterns here. And that's really the goal here. We're not just showing you how to reflect again, we're going to set up a problem with a reflection so we can then see how the numbers change if we happen to have our lines of reflection on the x-axis or the y-axis. There are certain things that change. So once again, we have a pre-image. We're going to graph the pre-image, we're going to graph the reflection line, we'll graph the image, and then we're going to observe these results to see if we can come up with a certain pattern. So let's plot our pre-image. L is at -3, 3. M is at 1, 2. N is at -2, +1. Okay, there's my pre-image. Now let's identify the line of reflection, which is the x-axis itself. So if you're doing this in pencil, like you're taking in the quiz, make sure you make that pencil mark dark enough so even if you're drawing on top of that x-axis line, I can see that you have put that line of reflection down in the correct location. Okay, let's reflect. Point L is 1, 2, 3 units above, so 1, 2, 3 units below gives us L prime. M is 2 units above, so 2 units below, there's M prime, and lastly N is 1 above, so 1 below the line of reflection, there's N prime. There's our results. So L prime is located at, go back to the origin, we're counting leftward 1, 2, 3, and then downward 1, 2, 3. So that's -3, -3. M prime is located at 1 to the right and 2 down. So 1, -2. And N prime is located at -2, -1. Alright, we'll come back to those numbers in a moment. Let's set up part B. This time we're reflecting the pre-image in the y-axis. So again, plot the original triangle. L, once again, is located at -3, 3. M is at 1, 2, and N is at -2, 1. Our line of reflection is in the y-axis. Make sure it's dashed. Make sure we can see it if you're doing that in pencil. And then lastly, let's reflect. So point L is located 1, 2, 3 units on the left of the line of reflection. So 1, 2, 3 on the right. There's L prime. Point M is 1 to the right, so 1 to the left gives us M prime. And point N is 2 units on the left, so 2 units on the right gives us N prime. Connect L prime and M prime and N prime. You can see there's a little bit of an overlap between the two figures in this instance. And let's identify the coordinates. So L prime is located at 3, 3. M prime is located at -1, 2. And N prime is located at 2, 1. Alright, we're trying to look for patterns in the numbers here, so let's take a look at these two instances. In part A, we reflected over the x-axis, so my object which was above the x-axis is now below the x-axis. So take a look at these coordinates from the original pre-image to the final image. Look at the x-coordinate and the y-coordinate. For each point, look at the x-coordinate and the y-coordinate. Look at the x-coordinate and the y-coordinate. Do you see a pattern here? What stays the same and what changes? You can see in each of these cases the x-coordinates stay the same, and the only thing that changes is the y-coordinate. And it's not even that the number is changing, it's that the sign is changing. What used to be positive is now negative. And that's because we are changing the height. We used to be above, and now we are below. And because these are equally spaced, not just over the line of reflection, but the line of reflection is on the x-axis itself. That distance above the x-axis is now below the x-axis, and so that distance is also the coordinate point. So this is our first pattern. Sometimes we'll use a comma b instead of x comma y, but it still means the same thing. We have a coordinate point. So if we have a coordinate point and it is reflected in the x-axis, like what we saw here, then the image is, so let's write that down as a rule. Here's our original point at a comma b. How does it change? Well, we observed that the x-coordinate stays the same. So no change to the x-coordinate. Here we're calling it a. And the b represents the y-coordinate, and that's changing, and the only thing that changed was the sign. So this is now negative b, meaning the opposite of b, meaning you change its sign. If we had started in the negative side, we would then change its sign to positive. So this does not mean make it negative, it means the opposite of b. Change the sign differently on that y-coordinate. Now let's take a look at the pattern in part B. So take a look at the numbers for your pre-image and image. Look at the x-coordinate and the y-coordinate. What stays the same and what changes? You can see here that the y-coordinates stay exactly the same. What changes then is the x-coordinates, and the x-coordinates are changing signs. That's because we're moving leftwards to rightwards. The height stays the same between L and L prime. The only thing that changes is whether it's on the left side or the right side. And because we're counting that distance from the y-axis, that distance is also its coordinate point. And so, if we have a point and we are reflecting it over the y-axis, then whatever that point happens to be, the x-coordinate changes its sign, so we write that down as the opposite of A, and the y-coordinate keeps it the same. We write that down as B in this case. So notice this is a good example of changing the sign. So notice in the case of point L, we changed that sign x-coordinate and it became a positive 3 on L. So again, it's when we see this negative a, that does not mean make it negative. It means change the sign on this coordinate. So this negative 3 became positive 3. This positive 1 became negative 1. This negative 2 became positive 2. That's what we saw here. Let's box this in so it stands out a little bit better, and that is a pattern that we've discovered. So now this is our third and final type of lines of reflections, and these are where we now use slanted lines of reflections. So let me back up just a moment here and remind you that when we are using a slanted line, the equation of a line is of this pattern, y equals mx plus b. Notice how that is different than the kinds of lines we saw when we were on the previous page working with the Vux-Hoy. When we were working with this pattern, we were using equations of lines that only had an x because it was a vertical line, or only had a y because it was a horizontal line. But if our equation has both x and y, that means it is not horizontal, it is not vertical, it has to be slanted. That means there's some slope and there's some y-intercept. Now, for the purposes of our reflections, we are only going to have a slope of 1 and a y-intercept of 0. What that means is the equations of our slanted line will look like this. Y equals x. That seems like a silly kind of way to write the equation of a line, but that's what you get when your slope is 1, because 1 times x is just x. And if the y-intercept is 0, then there's no number after the x. That means we will pass through the origin with a slope of 1. And then, if we have a negative 1 for our slope, then it would look like negative x. So in terms of our slope, either the slope is positive 1 or the slope might be negative 1. Either way, the y-intercept is just 0. Here's the rule. So again, we're using a's and b's instead of x's and y's, but this is our coordinate point. If we have a point and we are reflecting it across a slanted line with a positive slope of 1, then it changes in this way. The order switches around. So what used to be in back is now in front, and what used to be in front is now in back. If we have a point and we are reflecting it over a slanted line with a negative slope, here's our rule. It changes in this way. Not only does the order change, but the sign also changes. So again, be very careful. This does not say make it negative. That means change the sign to the opposite of whatever it used to be. So we switch the order and change the signs. So we have not even a triangle. We just have as our object a segment. This is line AB. These are the end points. So here point A is located at 3, 2. And B is located at 4, 1. Alright, that's our object. It's just a little segment. Let's reflect that segment in the line y equals x. That's this first case, this y equals x. What that means is we're going to take the coordinate points and switch them around. So that means my A prime will come from point A by taking the values of the coordinate and just switching around the x and y coordinates. So what used to be in front, the 3, is now in back, and what used to be in back, the 2, is now in front. Here for B prime, what used to be in front on point B is a 4, so put that in the back. What used to be in the back on point B is now in the front for B prime. Now I forgot to graph my line of reflection, so let me do that before we go on and plot the image. So This is my slanted line. Remember, the y-intercept is 0. That means we're going through the origin. And my slope is 1. So think of it as y equals 1 times x. That means a slope of 1 of up 1 and over 1, up 1 and to the right 1. And repeat that a few times. This is our line of reflection passing through the origin with a slope of 1. So then our A prime is located at 2, 3, so 2 to the right and 3 up. There's A prime. B prime is at 1, 4, and there's our image. That's the result. It's easier to see this happen with tracing paper. So let's take this tracing paper. Here is my line of reflection. Here is my pre-image, point A and B, and when we reflect this over the line of reflection, we're going to flip it this way. And so I'm going to flip this over so that the line of reflection still lines up, and you can see what used to be A is now here, and that's where we graphed A prime. What used to be point B is now here, and that's B prime. Here's the last one. This time we have a line of reflection that is y equals negative x. I'm going to graph that first. So that means we have a line that's passing through the origin, and with a slope of negative 1, that means down 1 and to the right 1. Repeat that, and then extend it in the other direction too, left 1 and up 1. And this is our line of reflection. Let me plot the pre-image. So again, point A is at 3, 2, and point B is at 4, 1. And we want to flip it over the line of reflection. We can kind of estimate it'll be down here somewhere. But in this case, we're not counting distances like we had in the previous examples. It's harder to count on the diagonal. We're just going to use the rule. So the rule says take the coordinate point, switch them around, so what used to be in front is now in back. What used to be in back is now in front, and then change the signs on both. Okay, so take point A first, switch the numbers around, and then change the signs on both. Point B becomes B prime now. Switch the numbers around, and then change the signs on both. And that's where we will end up graphing. So A prime is located at negative 2, negative 3. So 2 to the left and 3 down. B prime is at negative 1, negative 4. So 1 to the left and 4 down. There's B prime, and there it is. There's the resulting image.